Hello and welcome to this chemistry lecture series. In this video we're going to look at chapter 18 section 6, which is going to introduce something known as the iodoform test. This is another selective reaction like the ones we saw in chapter 18 section 5, where we're going to use a very specific reaction that creates the Tri-Iodomethane precipitate and use it as a test to identify a specific functional group, and more specifically here, a functional group with a specific carbon chain attached to it. So let's get started. Methyl ketone test, or what we know as the Tri-Iodomethane test or the iodoform test. Tri-Iodomethane is a yellow solid, a yellow precipitate, that can be formed with specific functional groups or as a product of a reaction with specific functional groups. Before we get into these functional groups, let's talk about the Tri-Iodomethane molecule. Like the name implies, Tri-Iodomethane is a combination of methane, or a one carbon structure, with three iodides, therefore tri-iodo. So Tri-Iodomethane will have a carbon with one hydrogen on it, and then three iodine atoms bonded to that carbon. So it is a halogenal alkane of sorts, a trihalogenal alkane. Tri-Iodomethane is not soluble in aqueous solutions. So this is going to come out as a solid or a precipitate. And not only is it a precipitate, it is a very distinguishable yellow precipitate. Tri-Iodomethane, or what we'll call iodoform from now on to make it simpler, is a compound that is going to be the result of a reaction with a methyl-containing carbonyl compound. Methyl-containing meaning that there are three separate types of compounds, three separate very specific compounds that can make or give us a positive test result here. Methyl ketones, which are going to be, and let me switch colors here. So methyl ketones, which are going to be a carbonyl group with an R group on one side, and this can be anything, it could be any kind of R group, and a CH3 on the other. So this is what we call them methyl ketones, because we have a methyl carbon on them, CH3 on them. And then the other side of this could be whatever. So this R group could be any carbon chain. So that's a little less specific. Then we have ethanal specifically. Why ethanal? Methyl ketones, because of their R group, can be many different compounds. But ethanal is the only methyl aldehyde. So methanal is going to be a carbon double bond oxygen, so we're going to have the same functional group with the same CH3 on one side as the methyl ketones have, but because it's an aldehyde, the other side has to be a hydrogen, because being an aldehyde needs a hydrogen on the carbonyl group, unlike the ketone. Well, because that side has to be a hydrogen and the other side has to be a CH3 for it to be methyl, this is the only methyl aldehyde we can possibly make. And therefore, ethanal will also give us a positive iodoform test. The last type of structure, or the last type of compound that can give us a iodoform, positive iodoform test, it's a secondary alcohol with a methyl group. Now that's a lot. So what exactly is that? That is going to be a secondary alcohol, meaning that it's an alcohol where the hydroxyl group is on the carbon that has a hydrogen attached to it. So we're going to have a carbon with a hydroxyl group and a hydrogen, an R group on one side, so some kind of carbon chain on one side, and a CH3 or methyl group on the other. So it's a secondary alcohol because the hydroxyl group is attached to a carbon, attached to two other carbons, where one side of the carbon has whatever carbon chain we want, but the other side has to have a CH3. That's what makes it a secondary alcohol. And we'll see why, because these two obviously have a connection, right? The first two obviously have that methyl group attached to a carbonyl group. Methyl group attached to a carbonyl group. This is a methyl group attached to a secondary alcohol, and we'll see why this has gives us a positive iodoform test in a little bit. But before we go into that, what exactly is the iodoform test? We do an iodoform test by essentially warming an unknown compound that we're trying to test with an alkaline solution of iodine. So the key here is going to be that we're going to warm this with an alkaline solution of iodine, iodine being elemental, oops, that should be a highlighter, iodine being the elemental iodine, I2, and an alkaline solution simply meaning that it has some kind of base in it. So it's an I2 aqueous in some kind of base that we're reacting this with. So I2 aqueous plus something like NaOH or a base. We're going to warm our unknown with this solution in order to carry out this test. So warming is one of the necessary conditions here. If we get a yellow precipitate from doing this, so if we grab an unknown, warm it with alkaline solution of I2, and we get a yellow precipitate, that's a positive test for one of these three groups. So if we get iodoform, remember that yellow precipitate is that iodoform we talked about earlier, CH with 3 iodines on it. If we get the iodoform, then we will have a positive for either a methyl ketone, ethanol specifically, which is the only ethyl or methyl aldehyde, or a methyl secondary alcohol. So why? Well, how exactly does this reaction work? Let's look at that. We're going to separate this into the methyl aldehyde and methyl ketone versus the methyl secondary alcohol. So let's look at the reaction with methyl ketone and methyl aldehyde or the ethanol first. The reaction that produces the iodoform with the methyl ketone or ethanol is going to happen in 2 steps. The first step is called halogenation. Essentially, in our first step, what's going to happen is that we're going to have our methyl ketone or methyl ethanol, methyl aldehyde, and we're going to focus on that methyl section because you might have noticed that all of these have that CH3 in them, right? In the first step, the 3 hydrogens on that methyl group are going to be replaced with iodine. So essentially it's going to be halogenated, right? So actually let me do yellow first. So that same methyl group that we saw earlier, that we have on the methyl aldehyde or methyl ketone, is going to have the 3 hydrogens that make it a methyl substituted with iodines. That is why this is halogenation, because we're substituting for a halogen. That's step 1. Grab the methyl, change all the hydrogens to iodine. In step 2, that same Tri-Iodomethyl group with 3 iodines is going to undergo hydrolysis. This carbon-carbon bond is going to break, and it's going to add a hydroxyl group on one side that's going to turn into a carboxylate ion, and a hydrogen on the other. So that same carbon is now going to be broken off with its 3 iodines, and a hydrogen is going to be added from the hydrolysis, creating iodoform. This right here that we have as a result, this is iodoform, which is a yellow solid or a yellow precipitate, as we saw earlier. So that's what the iodoform creates. So this is going to happen with the methyl ketones or with the methyl aldehyde, which again, the only one is ethanol. This process also creates a carboxylate ion Why carboxylate and not carboxylic acid? Again, remember that because this is in basic solution, we cannot have a carboxylic acid. We can only have a carboxylic acid in an acidic solution or even maybe a neutral solution. But in a basic solution, that carboxylic acid gets deprotonated and we get the carboxylate ion. And in this case, the sodium ion from the sodium hydroxide will attach to it, creating that salt, in this case, a carboxylate salt. Now, we can confirm that a yellow precipitate, because there might be some other yellow precipitates that appear in very specific circumstances. We can confirm that this iodoform test was positive and that yellow precipitate is actually iodoform by looking at its melting point. We can separate that solid, filter it, dry it, and then look at its melting point. And the melting point should be 119 degrees Celsius. So the melting point of iodoform is going to be specifically 119 degrees Celsius. Any yellow solid created that is not melt at 119 degrees Celsius specifically is going to be some other byproduct that's giving us a false positive. So this is what happens with methyl ketones and ethanol. With secondary methyl alcohols, something similar happens, but an extra step is added. The reason why a secondary alcohol with a methyl group also gives a positive iodoform test is because of an additional step that happens when we add aqueous alkaline iodine. Aqueous alkaline iodine, or essentially I2 aqueous plus NaOH, is a mild oxidizer or mild oxidizing agent, meaning it can oxidize compounds like secondary alcohols into a ketone. So what happens in our additional steps, so the middle two steps are the same, hydrolysis and halogenation. But there's an initial step that happens that is oxidation. The alcohol that we have gets oxidized into a ketone. So that carbon with the OH, let me make this a little bigger. So the carbon with the OH that we have in the secondary methyl alcohol will get oxidized into a ketone. That oxygen will lose its hydrogen, create a double bond to the carbon, creating a ketone or a carbonyl group there. So let me just circle both ways. It will create a carbonyl group there, and because it had that methyl, we now create a methyl ketone. The two successive steps after that are the same. That methyl part of the methyl ketone we just created gets halogenated into a Tri-Iodomethane, and then that gets hydrolyzed and broken apart into our iodoform and our carboxylate ion. But this is the first initial step that makes this possible. The alcohol getting oxidized by the iodine and sodium hydroxide into a ketone that is now a methyl ketone that can undergo that reaction. So we can oxidize a secondary methyl alcohol into a methyl ketone and therefore get us a positive test for the iodoform test with the same subsequent other two steps that methyl ketones and methyl aldehydes undergo. So that's it. That's the iodoform test, how it happens, what the iodoform is, and remember that we can test the iodoform by making sure its melting point is 119 degrees Celsius. That's the end of chapter 18, section 6. And actually, that is also the last organic reaction we are going to learn about in AS chemistry. So pat yourselves in the back for that. That is every single organic reaction in our curriculum. We do have 2 sections left, but they are going to cover analytical chemistry. We're going to cover infrared spectroscopy and mass spectra of organic compounds, which are analyzing techniques or analysis techniques. They're not chemical reactions. So you have now learned every single organic reaction in the AS chemistry curriculum. Now you're going to have to work at putting them together and visualizing those connections between them, and learning all of the different observations, conditions, reactants that these reactions involve. It's a lot, but it is doable with diligence and practice. So thank you for that. I will see you all in the next video to look at chapter 7 chapter 18, section 7, and the analytical chemistry side of the curriculum.